If you would have read the topic which I'll be speaking, it's little different. But we'll cover those connections and aspects related to the connections. I no need to read my name, at least you will be able to know that. Okay, and my company name, every details is there. If you want to connect with that email ID. If you want personal numbers, that we will discuss. This is the overall overview of that presentation. We'll go to an introduction about Larsen & Toubro, the work we do, and we'll speak of 2 projects deeply, then few more projects lightly, but we will be covering the schemes of those projects, how Precast is helping there. As you read the topic name itself, I am talking about Precast full-fledged. I am aiming at doing it everywhere, wherever it is possible. These are some projects which L20 is currently doing. If you don't know any project, you can ask. I don't think anybody will be having doubt on high-speed rail. These are some oil rigs to extract oil from seabeds. We take these structures inside sea, launch them and start doing those processes. Tunnels, there are many we have done and a few we are doing now. This is the stadium, which Narendra Modi Stadium. Again, this is complete precast. There are big columns with steel connections and grouted connections. This project we will speak, so I will leave it. There are express highways which we are doing, railways which we are doing. This is some U girder. If you people don't know, then U shape, any girder, if you are using that name, we are giving it as U girder. But the main benefit out of it is you have left out so many concrete quantities out of it and got that flexural behavior by making it as a U. This is the longest one currently in our country. These are some fastest projects in terms of buildings. 96 days, 96 flats, which we have achieved, I think, in 2022. This is, we achieved few months back, 45 days, a 7-story parking lot. Top part is a community center. That also will be speaking today's session. This is our precast factory at Mumbai, Navade. So this factory is tackling one project of ours, which is a big scale project. I will be giving a brief of that project. This is a first kind battery molds. So like you have battery cells, so similar way this is a battery mold we'll be using for preparing wall panels or slab panels, but basically wall panels. And he is our, SNS is our CMD, talking about bringing precast into a large scale domain into India so that we handle multiple projects with respect to precast. Now let's go back to the city from where I came. You can see large towers or skyscrapers and small dwelling units or jhopadis, you will say. And why I am showing this? Because we need 40 to 50% slum dwellers to move out and stay in a real house. So we need faster construction. We cannot wait. We cannot tell that, okay, after 3 years or after 5 years, I am going to give you house to live. At that time, this small unit will cover larger scales. So we need faster and faster construction. And what our government is aiming at? Doing the same. But there are challenges faced by government also. What cannot be compromised? Quality cannot be compromised. You cannot rush quality. So even though you aim at precast, your aim should be quality to be achieved. Then safety should not be compromised. I want precast, so I want something to get connected very faster. So I'll come up with connections which are just pins. Then certain safety aspects also I need to see. Then strengthening should not become the need for today. That means the live structures should not be aimed at doing strengthening, or from the day one we think that, okay, there are strengthening measures, we can utilize it from the day one. No. Life of the structure should go on, then strengthening or rehab should come. What we see in news, these are the news. Many bridges fell down, building fell down, people die. So main factor is people die. It is us who is getting sacrificed by doing construction which is not safe in nature. So if we are aiming towards faster construction, we should aim at giving that safety, stability to the structure, then to the occupant of that structure. Why precast? Many would have spoken, so I don't want to speak on them. Then type of precast, we in India only refer to this part of the precast, not this part where bolted or jointed connections are there. Yes, we are aiming towards that. But remember, as I told, we don't have maintenance available. We don't do maintenance properly. So if we go for bolted or welded or some type of steel connections or some type of pin connections, we should be maintaining it. So better to come back to same original methodology where you pour concrete, get the stitching between elements. That is like emulating the cast in situ practices. So that's what currently our code allows us to do, and many of our consultant practices. It's not like nobody is doing this. There are people who is doing that. But again, the client and the designer's wish. It is the client's call always in India what to be done. This is the force flow. If someone has spoken, then pardon me for 1-2 minutes. These two types of forces we are looking at. We are looking at some lateral loads coming from earthquake generations, that means earthquake generating it, or wind is applying it, some gravity loads. So let's take an example where I have precast or cast in situ foundation, then columns, and some distance between the columns. Remember, everything matters here. In precast, you don't have redundancy to go on or freedom to move on. You come up with a beam of certain length. Now, if the length is very short, what will happen? These will crack and this beam will fall down. In many metro projects, you would have seen some beam fell down. It's only because those bracings provided to those beams are not proper or not properly sitting. So if the member is not properly sitting, it will fall down. So same thing can happen in precast. But in cast in situ, if this is deviated by 10-15 mm, I will increase the length of the beam by 10-15 mm. And it doesn't matter in calculation because in cast in situ, redundancy is still present. But in precast, we need to ensure it. So we need to ensure something, bearing lengths, some minimum bearings given by the code should be followed. Some minimum tolerances given by the code should be followed. And extra reinforcement based on design, then doing the stitching. So that ensures us that we get a moment resisting frame or the frame we are requiring. We may have a simply supported frame without having those yellow color or orange color reinforcements. Now in precast, tie is a main requirement. I think this project should have been spoken by Satya Silan to you. If not, I'll quickly explain you. There are various ties written here. All these ties are taken care by code given by different equations. Now you should be understanding, if you want to go and do design or practice precast, you should be understanding where it is coming and why it is coming. What is the need if I don't give it? So if you come to this structure, there are multiple structures standing without any ties. See, this floor is not built, means this floor is not restraining your columns to go away. So something would have been done by the designer. That means designer has already done some stitching of these joints so that beam and frame are together. Slabs are simply supported resting till I do that structural topping above it. Once it is done, this is a complete system. And this type of stepped constructions you can do in precast very easily, not in cast in situ. Not in cast in situ because in cast in situ your design and procedure of design are different. In precast you would have designed it initially with simply supported assumptions, then later stage with stitching and bringing it to moment resisting frames or something. That can be done here. And you can see there are many reinforcements which you are seeing extra laid. Those are the tie requirements, or some from the beam coming to the slab areas. Those are the tie requirements. Some from the columns coming to the slab areas, or some going inside the columns. Those are the tie requirements. That means you need to tie your elements together or members together to get your behavior whatever you are aiming at. If you don't do that, what will happen? Again same, some serviceability issues will come, leakage will come. Leakage is serviceability issue only. Then later stress strength issue will come. When you start seeing deflection, you start seeing member going away. We'll now come down to Jal Jeevan mission. I think many of you will be knowing it is going all around India to supply water to households directly by many schemes. It may be groundwater directly utilizing or river or treated water utilizing. And what is the aim of that? Providing household water. So you should be drinking pure water. So aim is towards that, providing proper water.
So there's one project that's going on now.
Yes. So these are the points which I will be covering. I'll focus on standardization more, and I will explain you where precast helps us. In cast in situ, those type of standardization you will not be able to do. You may not be even aiming for that, but in precast you can aim for that, have a centralized factory or centralized facility and supply those. So those things you can approach in precast. Now this is the scheme. You have groundwater, take it up to a pumping room, pump it to the OHT. This is my point of presentation today. Then distribute it to the locals or to the households wherever you wanted or aimed for distributing it. We'll speak of UP, then I'll see how we standardized it and expanded it to different other states. Here we are talking about 7 different districts. Those are marked, and about 3,000 different tanks to be made. 25 different capacities depending on village sizes. So if it is a larger village or 2-3 villages together, we may go for a 650 KL, or a small village with some houses, 50 KL is sufficient. Then distribution between them. So if you see, bigger chunk is between 50 to 175. Then farther as we go, those chunks are reducing or lesser numbers. 6 different staging heights. Why staging is coming? What height we should be storing that water? Based on that gravity, water will flow to the nearby areas. As high is required because if you want to go larger distances on ground, or if you have slopes to cover. Then 2 different types of foundations, open and pile. I'm not going to talk on them. Limited timeline. Here the project makes sense for precast. When the project owner or the client or the government says you that I need this and in this much of time. So at that time, once you start doing back calculations, you will see cast in situ is not fitting in. We will see why it is not fitting in also. Then how much of quantity of concrete or steel we are talking about. These are some numbers engineer love to show you that we have done this much. Then these are some basic terms for Jal Jeevan Mission. We will be only focusing on 3,000 OHTs, overhead tanks to be made, not anything else, not like laying the pipes or distributing it to the households. This is where we'll start. Let's do a cast in situ staging, cast in situ tank, and see the number of days required. 130 days, you just remember, that is where we will start comparing. Beyond that, whatever you see, there is an assumption that 15 numbers are required and 1950 man days are required total for doing this only single tank. And this starts with CIS wrapped till the dome completion. Now we'll see how much we can reduce in precast, whether it is going to be 50%, whether it is going to be 25% of that number. And as I am presenting, that is the real number I will be presenting. Wherever required, we will be optimizing these numbers. You will see I will change these numbers because we have projects in cast in situ, projects in precast to compare. So main part, if you see, 80 days I am spending just to make this tank at the top. Why? Multiple activities. You need to take concrete to that high. You need to pour in multiple stages. Then you have to have that much of scaffolding or shuttering required. Then you have a dome above it. For that you do those shutterings. All those multiple things are requiring almost about 80 days. So if I am aiming at precast, day 1 I will aim for only the tank, not for the staging. And what other factors are there? Transport, both are there in precast and cast in situ. We will see the demerits of precast and transport. Storage, both there, but there you can store it in factory, a centralized one. Here you need to store at every site. Security at every location because every site is there. And various additional activities like bringing laborers to that place, staying at that place or arranging stay at those places. So those costs are there which we will not be able to quantify. Those are not tangible. Then when you say precast, challenges are a lot. See, I am showing you a road. How to imagine that a crane will be able to move in this or a trailer will be able to move on that. And this is what happens when you target a village with larger sizes cranes. So for that also you need to work out, you need to find out what can go there, what can pass in there. Or you may not have any turning radiuses. So turning radius means where you will turn your vehicle. Cranes are larger in size, they need larger turning radiuses. You may not have. And what other challenges were there? Minimum distance from the factory location what we selected was 25 and maximum was 150. So we need to transport those elements or facilities to there. And this is the first kind we are doing. Nobody has done it. After we did it, many have adopted it. Then how to estimate those costs? If you are doing first time, you should compare. No, like somebody says you built a hospital. Go to a hospital, see it properly. Come back and neatly plan those. You will do it. But if something, no hospital is there. I want you to build a space station at ground. You cannot go to space station to see it. Nobody will share you the video to see what is space station looks like. So once you target that, you will do your mistakes, your learnings, and finally you will come out with a scheme which might be a space station, but who will say? Peers will say. Peers will judge it now. They will come. Once you do it, people will come to judge you because people want you to go down. So nobody wants you to go up. In that sense, you will learn a lot. Then what locations I pointed out, approaches I pointed out, and client approval. Once you take a new technology to anybody, if I say you this is the best water I have from Kashmir, it is directly from Ganga, will you drink? You will question me, did you do certification? Did you test for this? Did you see algae in this? Did you see bacteria in this? Whether you have added chlorine in it? So you will ask so many for a glass of water. Now for a structure of 3000 numbers, we will face multiple questions. This is what we did previously. Internally, inside our factories, we targeted to do a single staging with a single tank, multiple columns with a cast in situ tank. Because circular precasting was aim, we will achieve it, but slowly we are moving towards the tank. Let's come back where we started thinking container to be precast. Container to be precast in steel, not in concrete, in steel. Staging to be in steel and container to be in steel, both steel. Options worked out. Then precast staging with bolted connections that I showed you in the beginning. With a steel container, precast staging with coupler connections and with a steel container. You know steel, when you say, many clients will say that we don't want. Because you will say every 5 years or every 3 years I need to go there and paint it. See the bolts corrosion, welding are proper there or not. So as a client, I have multiple jobs to do. If you say concrete, I'll blindly believe that you have given me a good concrete. Okay? So that way we came down and logged that here, working out everything, comparing their benefits and costs. You will understand that cost for a steel staging will be obviously higher. And targeting, strategic target from the day one is 60% precast and 40% cast in situ. We'll see where we landed it at. This is what we aimed at. This is what we achieved at. And you see a small house here, that also now we are targeting this way, so that we do that also in factory, transport it, leave your that site within 20 days or 25 days. So by a month, we give you a structure which is supposed to take 130 days or 6 months roughly. These are the elements which got used. There is a term called H-frame, there is a term called U-frame, beams and slab tanks. There are connections, how that been done and how that been achieved at. This is something visually it will look like. This is almost about 5.55 meter outer to outer. Staging height varies like starting from 10 to 20. Then precast H-frames, beams, slabs and zinc alum coated steel container. This is Australian technology which we adopted directly because it is very easy to do at site and it requires very minimal time to do that. This is the connection at the bottom most. What you see in grey, those are cast in situ. You cannot remove complete cast in situ like you saw one precast foundation. I think few precast foundations you would have seen in this course itself. So in those few we are also targeting towards complete one block as a unit, not as individuals as units and joining them. So grey means it may be cast in situ. Then these grey beams are cast in situ plain beams. These are pedestals. From there precast H-frame starts sitting with grouted couplers, which I think would have been covered by some of the presenter. Then again at the top, reduced number of grouted couplers depending on the demand on those connections. This is how the steel container is being done. You can see individual steel pieces bolted together, some liners and complete one liner inside the tank which will be holding the water. Question is, will it be radiating heat? Will it be holding heat? So those states also done to understand how much heat radiation or storing of heat it will be happening in those tanks.
You import these sheets from Australia?
Yeah, there are vendors inside India. We don't do anything. Now, when I say that we are doing it first time, so we need to see whether we are doing wrong or structurally we are sound enough. So if you see these two dotted lines are the precast options, and the thick lines here and one dotted line here are the cast in situ options. We are off by about 10 to 15% from the cast in situ counterparts. But the base here which I am targeting is somewhere here, 120 to 180 kilonewtons. So capacity wise, strength wise, we have the reserve strengths. Behavior wise, we have the ductility whatever possible to be getting through a cast in situ demand or a precast conversion. So in that you will see two options being here. One is with H-frames, other is with single columns with individual beams. Both options were tried. H-frames were faster, and that comparison we will do here. I'm not playing with audio so that you can just see.
Those are the H-frames, huh?
Yes. Finally, this is the U-frame. Completely everything is standardized here. Even this staircase is 3 types. Then these beams are almost about 700 deep so that we get those development lengths achieved. Then every slab planks are connected to get those tie. Then the tank comes which is zinc column, and completely we get this staging done with the tank. Let's now come to the numbers. Precast and cast in situ. From the beginning I told you 15 days, 130 days, man hours, just multiply those. You can see 8, 25, we have reduced from 130 to 25, and 200 man hours only, man days only we required, 90% saving in workmen, 81% saving in construction time. So from 130 days to 25 days. And if you see, this is the cast in situ with so much of staging. This is the precast, a crane laying it. Some colors you are seeing here, these are the bracings which is holding those elements together before grouting. Then we got that enhanced quality because we are ensuring it is built at factory. Connections are ensured with proper grouted couplers. Then once you come to a office, you will say that how many days you started claiming those money from your client. You need to invoice. So every 25 days we can start invoicing a complete tank, which we used to take 130 days. In 130 days, 20%, 30%, 35%. Now nothing. After 25 days, 26 days, we will go with complete money. You just give us.
Is it not tied to milestones and achievements?
It is achievements. Now if you see, for those 3000 tanks, these are the numbers for the conventional cast in situ, and these are the numbers for the precast. You see 5850 to 600. So everything got boiled down, came down once you go to precast. But price has to be paid. We will see it in a building project. Now let's go to standardization. I told you here we'll speak a lot. Why to do standardization? There are many factors affecting standardization. You may from the beginning fix that these are the costs I will pay, but still I will do standardization because that man hours reduction will reduce a lot of amount. 45 hours it will require for a A1 seat. Now if I make that hour to 1 hour for a A1 seat, you remember that 45 hours I reduced to 1 hour. So per hour cost, if in India we average take out to be 200 rupees, I saved that much of money. So that's how that cost has to be diverted. Then diverting from the security, diverting from the land occupation areas. So you go to a precast cast in situ land, surrounding lands you are taking rented, so that you can stack your elements, you can stack your processes, cements, labors, everything. Those processes are gone, and you are doing it in a centralized yard. You can plan a yard in a low cost area, but you cannot plan a project in a low cost area because project is recorded every area. Now let's see standardization in terms of heights, whatever has been done. 10 till 20 all are 4 columns with same H frames. Only the thing is number of H frames I'm changing. Ultimately we may pay slight change in this U frame at the top to manage those height differences. Then tank sizes, if you see, these sizes only we change. That means the top beams, which are linear elements, those can be cast in a long line mold. So those element lengths we are varying, and that's how we are coming off from 50 KL till 275 KL. I will show how to go for a larger scales also.
So you design once and build many.
Yes. If you see the staircase, you see these numbers here, 260, 260, 24 and 24 are the number of drawings required if you are doing a cast in situ design and drawing it every time. Now when you come to precast, you standardize it to 6, 4, 4 and 3 and you don't do. You just program it so that software does that for you. You just tell that, okay, I need this type of 1750, 1197 staircase. It will just give you set of drawings already pre-built in one goal, one project goal. Then similar way the other lengths and heights are adjusted and kept pre-built so that we can just pick out from that software or pick out from our drawing sets, change the project names and submit it. We will see how that is being done here.
Stairs are precast or
These are steel, structural steel. Because if we go for precast, I need to come up with connections here. We don't want, in steel I can have bracketed connections very easily and the client's requirement is this should not touch ground.
Yeah, otherwise
People, daily will go up. So to avoid that, you need a hanging staircase here. That cannot be done in concrete. So that is steel. So one steel means complete staircases are steel. Again here one steel staircase only can come. Those are the reasons we are going completely for the steel staircase. Now coming to cast in situ, you will require all these steps to be done for every project. When it comes to precast, all these red crushes you will do for once. One set you do, prepare it, make your time, dedicate it. Once you keep it, every time you start reusing it. And don't model also every time. Whatever changes are there, you change it at locally. Don't try to change the complete global model. If that is happening means you need to remodel everything. So here also as I told you, H-frame sizes are fixed. I need to add one more H-frame means I just need to copy that much of program, paste it. If you are doing in STAT, if you are doing in ETABS, just take it to Excel and write one more row that this has to be done. So it is done by the program automatically. Now when it comes to sheets, this is the standard 4 sheets we are giving. Now what to be changed? Change here, change here, change here and change here. Just the locations, what names got changed, what items got changed, where the landscape it is, whether it is located at X project or Y project or Z project, and what height variations are done in the cast in situ part, which is done cast in situ where the level differences are coming, and what direction it is. Generally practices are north, south directions are given, so that also we need to add up. Now once you go to precast, you will have a factory. So here I will talk about few factories. The length of this bay is about 220, width is about 20 meter. Like that 2 bays are there. You can see those H is seen, U is seen here and planks are seen here and beams are seen here. So all elements are planned properly so that you take those elements and stack at respective locations. Stack only for 7 days. Once you start stacking for longer days, you start paying prices. You need more land to stack. So as fast as it leaves your factory, that much benefit it will give. That is the bay 2. These are the locations where these factories are there. And these are some sizes and some targets which have been achieved from those factories. Now when you do standardization, you start impacting or you start expanding. So what the weight IC part of Larsen & Toubro has done, they have approached CPHEO, the guidelines for water stagings and all. They approached them and told that we have finalized one scheme and please approve our scheme. We will give you everything, every details whatever possible, we will support you. Once they approved, it is now a document in central government where you can approach now multiple states. So now we moved from this part to this MP and Karnataka just by doing that. We are now slowly moving to Odisha. Odisha also we have so many projects, so we are now moving to Odisha. Then to larger sizes, larger scales. And as I told you, here is our initial target and this is where now we are. 10% cast in situ because as I told in the beginning, there are some cast in situ works from the raft foundation point of view. We are trying to make it a single foundation wherever it is possible. Later stage, those are also cast in situ wherever it is not possible to be done in precast.
I'm just having a curiosity. Why are you always going for a frame staging, not a shaft staging?
So shaft means I need to do a shell in precast and connect it. Dowel connections there is tricky. Very tricky. I'll not be showing, I think, on tanks. I'll just tell that. So now you see, as number of columns can be increased, size of the tank can be increased, and we can target till 650 KL for those larger tanks. We'll see how that compares with the cast in situ counterparts. In this slide itself, in cast in situ from 10 KL till 100 KL, everything will be 4 columns. You cannot plan anything called 1 column cast in situ tanks. Nobody has done that. In precast, I showed you minimal sizes. We can target a single column. Again, the behavior and design is challenging. Single column means single flexural hinge is going to form and a mass is sitting at the top. So you should ensure that whatever failure you are expecting will be occurring somewhere here. Then 5 column arrangement from 100 KL to 200 KL. From 50 till 275, 4 column arrangement with different height of stagings, different sizes of H-frames. Here 12 and 21 columns, but we can target 1 million liter tanks also. In precast, we till now didn't reach these higher capacities. We have restricted us till 650 KL because there are design challenges. There are other plants, slushing and water effects need to be considered further, where these dowel connections and all will be challenging to achieve, and confinement zones will be challenging to achieve. But we will target now those tanks with single column arrangements. As I showed you in the beginning, I have multiple arrangements, H-frames, where you have bays given, where the beams will be there, and bays where beams will not be there. But if you want to scale it upward to a larger scales, you need beams everywhere. So you can go for a single column arrangements with corbels and beams everywhere like a building systems. We'll see.
You call up for the entire height, you cast it together.
We can do that, but the heights are higher. Here we were seeing 20 meter. 20 meter doing that means lifting it and erecting it will be very challenging.
The tanks are made up of what?
Zinc alum tanks.
What is that?
It's steel plates. So that corrugated sheets, they are rotated, then jointed by bolts. Then there is a pest layer which will make those joints to be sealed. Then there is a liner completely inside the tank. We are now targeting cast in situ tanks to be converted to precast by walls. Challenges are the connections between them.
So steel coated with zinc alum.
Yes.
See, I had told earlier to one of your colleagues in abroad, they have filament winding. It can be got. Now for the tanks, we are making precast on the ground with this filament winding.
Yeah.
If possible.
So, but this tank is not even taking 5 days to build it at that height.
Maybe construction-wise this will be easier.
Because individual seats we are taking out, and in villages those roads are narrow. In tractor and small trucks we are able to handle these. We don't require those longer. And if you see, this is 4.5 meter radius.
You are fabricating there. You are just
Directly doing it there.
that's a very easy thing to do.
Now we'll go to mission 45. We'll first take a small case study to understand how precast can make you in danger or give you benefits, both. So if you see, this is a cast in situ counterpart building. Here if you see, this is precast counterparts. You see, this is terrace beam with the slabs. How many beams are there in the cast in situ? Because you want to distribute all these slab loads between these by two-way actions. When it comes to precast, all beams are gone, no secondary beams, only few primary beams are active. One is here, all peripheral beams, and all these are long SCS slabs, hollow core slabs you would have seen in different projects. Now, will it be beneficial? Cost wise, yes. See the quantity reduction, 25 in precast and 34 in cast in situ. 34 in cast in situ and 17. Almost half of the beams are gone. That means that much quantity you saved, but literally, ultimately, once you do comparison, that those saves you will not see. You will see cost hike. I'll show you why. And columns almost are same. 16 plus 1 means one column is short, somewhere terminated at the bottom. Now this is how the precast looks. Some foundation that is also precast with dowel connections. It can be a single column or multi-columns, that means small heights and then larger height columns. Then both the labels you have grouted couplers at bottom and the top. And beams, those are having ledges and cantilever slab so that you get those projections and hollow core slab sitting on it. Then on top of it you do a screed concrete with the screed reinforcement to get the diaphragm action. Now let's compare between the design aspects. Time period wise both are almost similar. Little flexible because beams are gone in precast. Column wise if you see, precast columns are almost asking 40% higher reinforcement or somewhere 100% reinforcement reinforcement because so many beams are gone. So distribution of forces are gone. Now direct forces are coming to the column. When it comes to beams, few beams are attracting more reinforcement, but most of the beams are attracting lesser reinforcement in precast because force flow path has gone to the column a lot. And same thing in the terrace beams also. If you see cast in situ was somewhere about 1200 mm square, here it is lesser, but few.
Sorry.
Yes, yes sir.
Because all the connections are overhead steel connections.
Yes, yes. That also can be played here. Now, once you see these steel increases are going to increase your project cost by 20% for a single building. Now, if you want to do for a single building, then 20% extra you have to pay. Now scale it up. Once you go for 200 buildings, you no need to pay more. The pay difference will be 5%. This is a live project, I am not naming it. The actual CIS is 25,000 cubic meter. RS 25,000 cubic meter and precast is 28,000 cubic meter. What is not done is no site activities at precast. I don't need a security guard everywhere. I don't have the challenge of cutting down those reinforcement and taking it and selling. This is what is happening at various locations in our projects. One day you lay those reinforcement, next day morning you come, those reinforcements are not there. At least those challenges are not there in precast. This whatever scale you saw, we are targeting 7 days. So 7 days I need a security at my site. 8th day my building is handed over, or the scope of that chunk is done. Nobody will come and cut the concrete part and take it away. He cannot do that. He need vibrator and all to do that. So this is from this scale we will go to the mission 45. Again 45 is the number of days we are targeting for a 7-story parking. We'll see what is the overview of the mission. Here I have targeted all three in a single goal because I showed you how standardization helped. Here I am not going to break that and show you, but I will show you that has been done in the design scheme itself. This is the target. We have G plus 6 floors of parking, that including the ground. At the top you have a community center. This is how the site was looking in the day one. You have about 21,000 square feet area. 6 days cycle between the floors, 2,250 elements complete total. Then installed with a tower crane located somewhere here, it is standing here, and a mobile crane all around. We will see what are the challenges are there in that project also. So if you see, this is the location where we are targeting. If you see, these areas are not accessible. There are already projects available, already buildings standing. Now if you want to do project here, you have only this L available. So we planned initially in the beginning to go with a tower crane of larger capacity, and built up area if you see 1.43 lakh square feet including everything, 21 into those 7 or 6.5 it will come. Then other facilities are also there. Now if you see the floor plan, this is the lane where your car will go up or down. Then you take a rotation and park anywhere in the parking areas. Almost 60 parking areas are there, and this is how the framing is done. If you see hollow cores, you can imagine it is going to come. It is almost like middle beams are deleted, like I showed you in that small building, and these spans will be spanning through the hollow cores, and framing is ensured. And shear walls are well positioned. Some are here, 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 and all these ramp areas, shear walls are projected so that this ramp is done. Challenge is doing that ramp in precast.
I just have again, it's a curiosity code maybe from an academic, that in the center, why are you not continuing that beam for a better framing action?
So actually, what we did is we splitted it. So once you see these forces are targeted here, we targeting here, we are targeting here in the staircase zone and lift zones, and targeting here in these zones. So these zones, whatever is there, very minimal is available for that. And if I continue these beams, my hollow core stops. Once I stop a hollow core terminates abruptly. You may not be able to get that 1.2 meter.
How's the hollow core layout?
Hollow core is running like this.
Okay. But, okay.
And here hollow core is running like this. Hollow core is planned perpendicular to those beams, so that it directly rests on two beams. We'll see how those connections are done. This is the ramp area. Here complete precast. Ramp is also precast, made of hollow core slabs. That is the challenging part, because in the ramp, if you don't have the proper slopes, your vehicle will not go up. And hollow cores always have cambers. So you should plan your cambers thoroughly so that vehicle doesn't feel that bumps. Otherwise, somebody going through that parking lot will tell you that I have bumps to ride. That means the slab is not uniform. So those.
Span of that from beam to beam on the ramp.
So I think 7 meter, little less than 7 meter.
In fact, we have now 20 meter span that we're working on with all of our slab.
So possible.
We get rid of all the middle columns.
Yeah, but sir, if you go to 20 meter spans, you will not be able to get that much of load, 7 kilonewton per square meter or 5 kilonewton per square meter. You are targeting the deeper hollow cores. 300 itself? Okay. This is how the cast in situ part is done. Till the plinth locations, all are cast in situ. Actually, the project is supposed to happen in cast in situ. As I told you, targets from the clients are much higher. They are now reducing the numbers to much lesser. So if the client is giving you nowadays, if they are giving you a project which is supposed to take 2 years, they will tell you, we want in 6 months. So you will start with 6 months, you will negotiate then 7, 8, 9, like those it will go on. This is how the crane is located, centrally one crane. That means these areas all will be done by the crane or the trawler crane moving all around this part. Then the crane will be removed out and this part will be completed by a mobile crane or trawler crane. These are the connections. I think Satyasilan would have shown you these type of connections, but L20 has a different practice. In the corners also they a little different, and waterproofing is taken care by the connection itself. So backer rod, then sealant, then flushing of those connections so that water doesn't get in. That is being practiced now in those connections. These are for hollow core to beam and hollow core without any cutouts. So wherever ties are required, hollow cores need to be cut, filled with concrete with extra reinforcement in this shape, or some locations we follow this part like this, like this, like this, and like this. Then extra reinforcement at the top wherever we don't have the cutouts. This is how the column to beam and column to column connections are done. All are grouted couplers. Challenge is matching all those 16 or 20 reinforcements directly with the couplers. So you need a template. Always good practices having a template from the day one, because that will ensure that you have proper match between the bottom and the top. And beam to beam connections are like some reinforcement getting into the column and top reinforcement moving at the top. Again, if you have higher moment demands, if you go for complete moment resisting frames with higher moment demands, then you may need continuity in the bottom reinforcement also. That being achieved in a different manner. There are PIC connectors that can be done in that. And if you see, there are ties. So all those ties I showed you, here I am just showing you internal ties, how those are kept in the top of the beam so that it ties to the hollow core slabs. If you see, one hollow core is resting on the beam, ledge or corbel of the beam, and other hollow core is just in the face of the beam. So those cases are there in our plan. Now, few interesting connections which you will not see from other projects I am showing here is a hidden connector only used for staircase landings, because see, this shaft is completely ready and now we want to install staircases. If you want to do that, then either you stop those walls at those locations, keep those planks, or give a wall corbel, keep those planks. But these hidden connectors avoid those things. You just need to have a pocket in the wall. This connection part extends and goes into the pocket and you pour concrete in that. This is how it will look like, and it has certain capacity restrictions and one company giving it. So these intermediate landings are done like that. These yellow color flights you are seeing, they will directly rest on those landings. Few extra concreting or extra stitching will be done to connect those flights to the landings.
Should I consider this connector to be a mechanical connector?
Yes.
Is These are mechanical.
Mechanical, but completely hidden in concrete. So there is no chance of getting damaged.
Corrosion-wise,
Corrosion-wise, it is protected. This is how the live project looks like. This is the connector inside a reinforcement case connected to the mold face. Again, maintaining the slope and all matters. Otherwise, it will not match with the pockets. This is how you check those connectors whether this is getting pulled or not. Once you install, you will not be able to see those connectors. Somewhere here, those two connectors, and here, those two connectors are there. These dowels are kept so that your flight comes and rest on those dowels and you grout those. You can see here somewhere or here somewhere. Now coming down to Mission 45's plan, day 0, 4th of March, crane is standing and elements are scattered all around. Almost about 1 floor elements are scattered all around. Start doing it by day 10, floors are done. We'll see the sequence, and by day 45, actually 42, this building was ready to inaugurate.
again, I'm not very clear, how was the foundation done?
Foundation is cast in situ.
Is when you are saying day 1, the foundation is over.
Foundation is over. We'll see that animation now. So now the foundation parts are done. Dowels are protruding up from those foundations at all location of columns and walls. Walls are erected from the top. Then columns and individual planks of walls are erected. You can see those bracings given. Then floor beams and hollow core slabs are erected. You can see those dreads. Then structural topping at the top, 75 or 100 mm depending on locations will vary.
Why do you need such a high topping?
So because we have electrical pipes.
See, parking garage, what happens is since it is exposed, I believe you are providing slope.
We are providing that.
Slope. That's the important. I mean, in buildings we don't need, but where in parking garage, we have to provide slope. Otherwise, when you got a stagnation is a problem.
Yeah.
And you place like Mumbai.
Our complete windows, that parapets are open.
Yeah, it's open, right? Yeah.
This is how the bracing of those columns are done.
Good question.
Yes.
Here on the foundation, looks like you had mostly strip footing and some isolated footing.
Yes. Then sequence of installation goes on. Finally, we complete on 12th. Finally, we complete on April, starting from March. This is the part which is extending in the 7th floor.
Just from, just
Yes, sir.
because I feel parking garages, precast is the way to go. In fact, I don't know, I think Mr. Amlan would know. There is a famous consultant, a Walker consultant in the US. They do only parking garages, both construction and maintenance. And they don't do anything else. Right? So I think that's interesting, but from Indian point of view, we don't look at the life cycle cost. What is your savings in time plus the initial time, let's say initial cost? Or you off by 5%, 10%, roughly?
We're off by about 12 to 13%. But
how much time you are able to?
45 days. We would have taken, I think, 8 months to complete this.
So that offsets it.
But proper planning. That 45 days is not talking about something called the back planning. A month planning going on in the
Say
back.
90 days, if I'm able to save 6 months, instead of 9 months, if I'm able to finish it in 3 months.
That is true.
So 6 months you should save.
Thing is that 8 months or 9 months is a virtual situation which never occurs.
I know.
The DRDO, they had demonstrated one project roughly about the same time, roughly about the same size. They did somewhere, I don't know exactly where, maybe they did. Dr. Radhakrishnan, who is our acting faculty, he spoke about that. DRDO demonstrated this first time construction. By the way, DRDO, again, this is for the students, does not mean that there is no civil engineering. There are lots of civil engineering. That's why for job opportunities you can think about.
Now we'll see some fast track projects of L20. This is a building project of SIDCO. There are many. One is cast in situ. This is precast, again cast in situ and precast. You see the numbers in precast, 11,000 and 5,000. In cast in situ, 7,000 and 5,000. Projects are almost done in cast in situ. In precast, this is the new one which I think they have started with 12% growth in that, 12% complete. Here in Kharkopar, this number is now 70% is done, almost handing over is going on. And when you see dwelling units about 29,000, and in Mumbai 325 square feet and 350 square feet are the 1 BHK. When you go to 2 BHK, 500 and 550 becomes the good 2 BHK. 3 BHK starts with 650. So those numbers are those numbers for Mumbai. At least don't compare it with your houses. Maybe in this part of India it will be much larger. When we say 1 BHK, it will start with 600 square feet.
Okay, I just need to know the Gulbarga project.
Yes, sir.
Compared to that, what are the improvements over this about
It's a lot. Connections are completely changed. They are now adopting connections which will ensure in the beginning that leakage doesn't occur. Water treatment process is completely new, and the liners or the sealants they are using now is completely developed. Then all those screeds are done with a compound, crystalline compound, so that they themselves become waterproofing in the larger goal. Crystallines are dangerous because they take time to get activated. There are now activated systems, enzyme activated systems, which will get activated in one rain, but they need moisture to be alive. So that's how those systems are now changing. Connections they have changed a lot, so that they don't get problem. And starting from 2 units, so if you see this 3D wall having only 2 windows, now they have gone for larger 10-meter wide walls directly, so that they don't have joints, minimal joints, and joints are strategically located so that water leakage, if it occurs also, it doesn't hamper the building functions. So that's how slowly those companies are changing their ideology. All toilet and kitchens are now becoming pods. So they themselves are a unit, they are monolithic itself, so that water cannot seep in from that to the structure itself. There will be a water path, from there it will go. And various other wall elements you see, and then this is double pod element where only the top slab is done, so that 2 toilets are there. You can see units are different. So 1 bedroom, like that it will be planned. In the beginning itself, from the planning stage, we'll plan the precast scheme. Otherwise you cannot achieve it. If you want to scale a cast in situ where that toilet is there and another toilet is here for the other side, then making it precast will be difficult. But if toilet is here and next to it from the other building, then you can make it a single pod and get rid of those leakage issues. This is how, as I told you, this is a 10-meter wall now. From this end to this end, having 2 bedrooms or 2 halls, completely with a single wall. So joints are minimal, leakages are minimal. In precast, first question comes how you are joining. Then battery mold, ensuring that you do a vertical pouring of concrete. Having a good quality of concrete, proper packing, and lifting issues will not create any cracks. Secondary activities creates crack in precast elements, like lifting it, tilting it, transporting it. So now if you cast it vertically, you transport it vertically. Here if you see, these are having windows, chhajas pre-made. So second stage of chhaja building is not there. And right now L&T is practicing like all your windows will be provided with granites, liners directly. So that also is done properly, so that you don't have leakage through granites to the precast units. Sorry. These are some pod units, as I told, and this is how the pod reinforcement casing is done. All electric pipelines, everything is done. Where pipelines cannot be done, like we don't know, the changes will be there. There the slots will be provided, so the plumber can come and do the pipeline based on his wishes. Now we'll go to one more fast track project which is already completed. Track slabs. You all will be knowing metro. If you go to metro, you will see plinths. Above that the rails will be there. Making that plinth itself is a challenge. You need to lay, ensure, and you should ensure that quality is there, because rail is going to move above it, or train, that 17-ton load is going to move above it. So for that, what has been done is, these are precast units. Above that, all fixtures pre-positions are there. I will show you how much challenging it is to achieve those goals also. This is the length where we are talking about 209 track kilometers. That means those many, that when you say up and down tracks, both are considered here. And this is how those track slab looks. These are in accuracy of 0.3 mm. Now, when I say 0.3 mm accuracy, I require between these positions so that they don't deviate. You should be measuring that. You will see there is a machine which is costing a lot to measure those, and it measures those points and graphs it and compares it to a template, ensuring that those 0.3 mm accuracy is being there. If it deviates, there should be a method to repair it or reject it. There are certain deviations where it will go for direct rejection. Right now, rejection rate is very low. This is how the plinth will be connected to the below structure. So below structure, when I say, it may be a deck of your box girder, deck of your U girder, or deck of your I girder, that slab part. Then these color parts with extra reinforcement will be there, and this part which is white in color will be coming as a precast. Somewhere like this, these are those colors where you will pour concrete, and these are those facilities where your rail will be resting. On that, you will have a elastomer, rail pad, and rail locking arrangements, all with different thicknesses. And changeovers will be there. Rail will change. The first slide itself I showed you, changing is occurring between the tracks. So these spacing should vary, or the type of this element should vary. So those also has been taken care. This is how it is prepared. This is Germany made mold. Mold itself gets accuracy test every repetitions. Every 10 repetitions or 6 repetitions, we target that mold accuracy will be checked, so that mold doesn't go with any deviation. Reinforcement caging is done with robotic arm and human interventions. Then concrete pouring, fully automated. Vibrations with proper manners. See, the client was not allowing bugs also. Bug holes are the small holes. Client was not allowing that also. So specially made flat vibrators were bought so that those bug holes can be removed from the side surfaces. Then casting it, after that handling it, that means rotating it, tilting it and stacking it. All those processes are taken care with automations and minimal lever interventions. If you see, there are 3 levers here, 3 levers here, 3 levers here. Almost everywhere you will find 3 to 4 levers only, not more than that. And fully automated factory, when I say everything, that lever can operate from his remote, tell the batching plant, send me concrete. The hooper will bring the concrete and pour to the required position. Lever will operate it and open those valves just to pour the concrete.
Can you just go back to the previous slide?
Yes, sir.
This green color is cast in place? Or
Yes, it is a grout packing done at site to lay it at the level.
in the building, this was just the reverse.
Yes.
Since you have a filigree element, which is precast. On top of it, you put cast in place. You have something
To get the continuity.
But here you are doing
Reverse.
But you have to make a shutter for that.
No, only here I need to have a packing.
For the green color?
Here I need to have a packing. Here I need to have a packing. That's all. So if I show it on this slide, so if
Green color.
this is just the packing I am doing. This is just the packing I am doing. I am pouring from this.
The green color is
Yes,
cast in place, or-
cast in place. I am pouring from this gap directly. These are the 2 pockets which is left. I am pouring from that. So if you see
And then
here and here, those 2 pockets will be coming.
shuttering.
No shuttering is required. That element itself is shuttering for that. Only at the side you will require those packing.
Can you go back? I think that's what I'm not showing.
Yes.
Yeah, the next one, the picture that you took. Yeah, here. No, the installed location.
This one? Okay.
So that, okay, so you pour it through that opening and then it comes.
We pour it from here. And this is grout.
Kind of reinforcements of cover block.
Correct.
Okay, I think I misunderstood. There is another precast element at the bottom.
That is not precast. That is the deck slab of your element. It can be a box girder top slab. It can be a U girder top slab or bottom slab, or that is your bridge. Above that you are making this plinth.
Then you don't need shuttering.
Yes. Now this is the ferro machine, almost about 20-30 lakhs. Just to ensure that all these points are in 0.3 mm accuracy between them. If it is deviating, see, the length is about 3.8 meters. In that 0.3 mm between these 2 points, so what this operator has to do is just change these positions for 4 corners or 6 corners or 8 corners. This machine tracks that and takes those readings. It gets compared with a template which is already there in the system, and From that we get a 3D space, and we will know that how much deviation is there between the template and the casting element. Any deviation can come from the mold, from the casting, or pouring of the concrete. Everything can be happening. So this is the mold face. It is casted ulta, reversed way you have casted, so that mold face is giving you that sort of finesse. Let's go to one more project, MHSR. In that I will end. Saddle carrier, this is about 1000 metric tons, and this has a capacity of about 1500 metric tons, made by L20 itself, but first it was done by China. China has done it earlier. Started from Sabarmati till Mumbai, almost about 78% of this length is with Larsen & Toubro. And C4 is the package from, I think from here till here, Ahmedabad till Vapi or somewhere, that will be the C4. We are covering 12 stations. That means every 50 kilometers, one station will be coming. Towards the end, the station gaps are little closer. Then maximum targeted speed is 350. You all will be reading it, so mostly will be knowing what will be the achievable target, and travel times will be 2 hours 7 minutes. See, these are not dream projects. See, once this project comes, Mumbai cost of living, the house I stay is 350 square feet, rent is about 35,000, and outskirt in Kanjur. So if you go to heart of Powai, same square feet will go to 70,000. If you go little further to Marine, same square feet will go to 1 lakh. Now, if someone living at Vadodara or someone living at Ahmedabad at a cost of 5,000, travels, comes to Mumbai in 2.5 hours, does his job, go back and stay at Vadodara or somewhere outskirt. Not Vadodara, Vadodara is far away, but somewhere outskirt. He saves lots of money. That chunk of money is the target for government to get it and invest in other growth projects, so that we get those things done. Targeted passengers is 750. If you read these numbers, you will find it different in internet. This is the scheme. Start with a big reinforcement cage. Cage itself is 250 metric tons. Pour concrete, which takes days. Then make those elements, make it travel through a carrier to the position where it gets launched to a span itself. So initially you choose a location, 6 locations are chosen in this stretch, where you choose a location where you have a big gantry which can carry this, keep it on here or keep it on the carrier. There is a transporter which carries this along the length. So 6 location means, let's assume 50 kilometer. It carries for 50 kilometer, but not that way. Both way it is actually 20 kilometer, 25 kilometer. Like that it carries the full load to the launching girder. So launching girder is sitting somewhere here. That gets fed and launching girder takes it and launches it to the span wherever it is required. This scheme is FSLM, full span launching method. In that what happens, you saved a lot of jobs at site, no post tensioning, no cable installation, all those are done at yard, and complete design is done by Japanese. However, I am lucky to see the complete process through IIT Madras, and the complete design with various other challenges has been verified by IIT Madras in that sense. So once you launch it, you get your span and move ahead. Launcher moves ahead. And launcher positioning is a very tricky positioning here. I'm not able to zoom into this picture, I think. If you see, launching girder is standing here in the pier where the girder is going to be kept, and standing here, not in the back span. Not at this location. This location, it is just resting on that traveler which is bringing your span. Now question is, when you get this design, you will understand that you have 2 waves only. And bearing locations are different, waves are little different. Where to keep those launching girders? These are very much challenges. And client demand is, wherever you keep, it has to be a web when you are launching it. When you are keeping this girder, only on the web this can be kept. And when launching girder moves, it requires stability. See, waves are, let's assume, 5 meter apart. For moving of launching girder, we need much more spans. So here at this location, arrangements are done such a way that we can move this way. So the girder you are seeing itself has facilities here with multiple ramps, so that you lower those, or screw jacks, you lower those, launch the element, you move those and move ahead. So this span moves, goes to the other part, which may not be there in this image. Yeah, it's not there. So if I say, if we started here, we moved here, further now we are moving to this span. So like that, it is moved for getting those spans. Now we are coming to the summary of this presentation. Every slide you got one project of Larsen & Toubro as a slide breaker. All those projects starting from Ram Temple till Sardar Vallabhbhai Patel statue has been done by us with different schemes. Ram Temple is a scheme having 1000-year life prediction. So all those service life estimations and all are done. Seismic, site-specific seismic activities were done. Coming to summary, you all know speed, quality, all those are precast benefits. I'll only tell that standardization is much required. Once you standardize, you make your minimal efforts to be done for further projects, and what you get is sustainability by that. And precast is not friendly. You do mistake, cast in situ has redundancy, it will transfer. So let's assume one beam of your cast in situ project cracked. Force transfer will occur to the next beams, redundancy of the system will help you. I showed you the project where I had only one middle beam. That beam goes away, torsion with the first mode. Suddenly the mode changes to the torsion. Now if you pay price, you have to pay it from the day one itself with a good engineer, good scheme, good connections. Any one place we pay price, that means we give away. We don't consider that to be important. Your structure's behavior suddenly jumps to a torsion governed structure, or a structure which is failed in serviceability. You will find multiple precast projects in that sense also. So that's where I end. Thank you.
Any questions?
You can ask any question on any of these images also.
Since I know from your student days, what do you think in the industry you are facing, which you feel should be covered in a university curriculum?
It's a proper design. We don't have proper designers.
We're not a proper designers.
I can say now, sitting in both the sides.
No, that is